And I'm here today with Peter Lederman from Soundsmith. Good morning, how are you?
Well, I appreciate, Peter, you're coming by. We're thrilled to be here in Newport, our first show here. We have, of course, the speakers, the Monarchs and the Dragonflies, the Soundsmith amplifiers, the strain gauge preamp.
Let's look at that, viewers.
And again, this is designed in part with women in mind.
Oh, look at that, it's beautiful. Look at that, here's the volume control. You go up, you can go down, it's beautiful. Look
The
at
lighting's adjustable. Inputs are done by color, so you can see what's going on from across the room. Lighting's adjustable. You can ramp it all the way up or all the way down.
Yeah, also, I think that the audiophile likes to sometimes have it off, so they feel that at times the LEDs can affect the sound. What's your opinion on that?
I listen with my eyes closed.
Oh,
It's the best answer I've got.
I do too.
All right. We're here also with the strain gauge, of course, and the Hyperion cartridge. I wanted to talk essentially about the Hyperion because what I enjoy doing is doing things that are breakthrough in design. There are a lot of engineering aspects to various articles in audio where people did things 30 and 40 years ago and the engineering stopped. And I love to look at those and say, how can I apply modern thinking or concepts? One of the problems with engineering very often is that you get something to work, frankly, and life says, great, you've got it to work, and move on, and then it just sort of gets forgotten. So what I've done with cartridges is work on a number of things. Number one, I like to design cartridges from a very commonsensical standpoint, from basic physics, sort of physics 101. One of the things you need to do is get rid of the moving mass, or at least minimize it at the back of the cartridge.
So this would represent the cantilever, viewers.
Stylus, suspension.
Got it.
And you really want to get this mass down as far as possible, because if you consider if you had a broomstick glued into a brick wall and you pluck the broomstick, you don't have to be Enrico Fermi to figure out what's going to happen. The energy travels up, it hits what is called a mechanical impedance mismatch, and the wall can't absorb the energy, it reflects back down, and the broomstick does this.
Understood.
This is what happens with phonograph cartridges. And when you reduce this moving mass, you're reducing that effect. Now, obviously damping is used to try and minimize this effect and get as much energy off into the damping material as possible, but a substantial amount of energy does reflect back down.
And how do you deal with that?
Well, one of the things that we've done with our Cicero cartridge and some of our other high-end cartridges is to minimize this mass, which we can do with a moving iron design, much better than with other magnetic designs. We've also paid a lot of attention to how the energy can propagate into the body of the cartridge, getting a proper mechanical impedance matching. Still in all, as well as you can do that, energy still propagates back down the cantilever. And here's the problem. The stylus in the groove is a real mechanical impedance mismatch. You cannot put energy from the cantilever into the stylus and into the record. So the stylus rattles around in the record. It's a whole slew of problems. What we've done recently with the Hyperion, our next advance, is to get rid of the super hard cantilever materials and go to a cactus thorn, or cactus spine as it's properly called. The internal structure of the spine is stacked columnar cells wrapped with fibrous bundles, and this whole arrangement is in a tapered assembly to further minimize the mass and increase the geometrical strength. So it's almost as rigid as the super hard materials, the boron, the ruby, the sapphire, diamond.
Understood.
But it has much less mass, but most importantly, it absorbs energy that travels through it at the right frequencies. So the energy that would normally propagate back down the cantilever doesn't make it to the diamonds. The diamond is very still in the groove. By reducing the moving mass, we've moved the resonant frequency of the cartridge, this natural resonant frequency, way up. Which is terribly important. Even though in a moving coil design it's above human hearing, the sum and difference products beat together and flood down into the top of the audio band and cause the stylus to jitter. So the stylus is not in intimate contact with the groove wall. You lose detail and you generate what sounds like groove noise. A lot of folks who listen to our cartridges say, why are they so quiet? And the answer is the resonant frequency is pushed way up high, so the jitter is reduced at just above the audio range. It's pushed way up much higher, so the sum and difference products don't flood down. Two immediate benefits: quiet in the groove,
Yes.
low jitter,
Yes.
lots of detail.
Yes.
So again, taking care of the stored energy and propagating it into the cartridge for the arm to deal with, going to this very radical cantilever design, all of this gives you lots of micro detail. So we love to shine a light on engineering that stopped 30 or 40 years ago and say, where can I make not just a small improvement or something that looks good for marketing, where can I make a dramatic input? Now the Hyperion also has an unusual warranty. It has a 10-year warranty, manufacturing defect, plus free retipping of the diamond to the original owner for 10 years. So it's a very interesting high-end purchase.
What's the MSRP on the Hyperion?
It's $7,500, and it works into a moving coil preamp with a 1,000 ohm load, typically about 1,000.
And what's the output?
0.4, so it's very typical of a low output cartridge.
And is that playing right now?
No, the strain gauge is
We're
playing.
playing the strain gauge, viewers. Let's take a look at that. And I think a lot of people in the high-performance audio industry have seen this cartridge, but they've never seen it actually playing live like we are today. And you can see that it has a LED light. Is that correct, Peter?
Yeah, there are two LEDs, one for each channel, which aids you in troubleshooting should you have an intermittent. One of the considerations in making a cartridge that'll go down to DC is if you have an intermittent, it could send a transient through the system. So the strain gauge system has automatic muting. It's always sensing the condition of the cartridge, and should it sense a fault in the wiring, it will mute the system.
And the rest of the system today, what arm is that?
This is a Schroeder arm designed by my good friend Frank Schroeder. He's, in my consideration, one of the finest audio engineers in the industry. And Harry Weisfeld of VPI was kind enough years ago to make me an arm board on the Hrx, which has recently caught on in a very big way, and people are asking for the Hrx with an arm board so they can have two arms. We love the Hrx turntable. I've used this for years, and of course, one of the beauties of it, as a cartridge manufacturer especially, is that if I go to shows, I can simply remove the arm and have a number of arms set up to play different cartridges for customers.
That's a JMW Memorial Arm, viewers.
Correct. And Matt Weisfeld is with us at the show. We're thrilled to have Matt here at the show representing VPI. And VPI also has a brand new turntable, if you'd like to turn to your left. This is called the Traveler, and we're very excited about this new development from VPI. The Traveler is their new entry-level turntable. Turntable sells for $12.99, and it is just a wonderful performer. Beautifully engineered by Harry Weisfeld, and we have the Soundsmith Carmen cartridge, which sells for $5.99, and we're running with a little Soundsmith preamp at the moment, and we've had just tremendous acceptance at the show here. It just sounds fantastic.
Viewers, yes, we saw the Traveler up in New York 6 weeks ago, and Matt gave us a great overview of the turntable. It's great to have Harry and his son in the business. Matt did a little bit of co-design on this turntable as well, and we do want to give him a little bit of credit for that. Absolutely.
One of the things that I enjoy about VPI products, having taught audio for many years and audio service, I'm not real fond of things that fail prematurely. I have a hard time with that. And Harry has the same philosophy. Harry overbuilds products so that they will last. I really enjoy that and appreciate that in a product. We had a classic one that we sold to a customer, and he had it on a shelf, and a week later it fell and hit a marble floor. And he brought it in for us to rebuild.
Yes.
But the bearing in the platter was perfect, and I called Harry. I said, Harry, I need a new base. I need a new arm repair. He said, what happened? I said, it hit a marble floor. I said, but Harry, the platter bearing's perfect. There's no play. It's not wobbly. It's not. He started laughing on the phone. He said, that's what happens when you over-design products to last. So
Very good.
Yeah.
Well, I want to thank you very much for being in the business, for supporting what a wonderful industry we have, making music, touching and feeling the records coming out of the sleeve, and we have great new technology to play them back with.
Well, I think it was Descartes who separated art and science. They are one. And therefore, since art and science are one, the purpose, I was told years ago, was to connect the upper realms, the sublime, with the physical world. So it's an important task, and people like musicians and scientists and people in the audio industry attempt to do this.
Well, your success with this and success with life. Thank you, Peter Lederman.
Thank you so much.
Very good, thanks.
Bye-bye.